Hey everyone, Dr. Hughes here, and I'm going to talk about a lab skill focus for this week, which is how to read a meniscus. In the experiment this week, you're going to be using graduated cylinders and a burette to determine the density of water or ice. I guess water in its liquid or in its solid state. In order to use this glassware, though, you're going to have to learn how to read a meniscus. So a meniscus refers to the curved arc that forms due to the capillary effect, which is how water is kind of sticky and crawls up the sides of the container that it's sitting in. So I've got kind of an example here of what that meniscus might look like. So this is an example of a portion of the 100 milliliter graduated cylinder, which is this big guy here. And here is our water line, and this is the meniscus. So again, due to the capillary effect of water, or its stickiness, it kind of crawls up the edge of the glass. So when we are reading the meniscus, there's a top of the meniscus, which is the top edges of where the water is at the top, and then there's the bottom, which is the bottom part of the arc. So when we read a meniscus, as a scientist, you need to always read the bottom of the meniscus, not the top. The other thing you're going to have to do is you're going to have to get at eye level with the meniscus. If you were looking way above, you can't really see where the bottom is. So when we are trying to get at eye level, you'll have your glassware, make sure it's on a nice sturdy flat top. And then right now, like here's the level down here, my eyes are way up here. I cannot read the bottom of that meniscus. So I'm way above. So I need to get to eye level. So I might have to squat down, right? So I'll squat down and make sure my eye is level with the meniscus so that I can read where it is exactly. So you'll have to go up and down and move around a little bit when you're trying to make sure you're at eye level with the meniscus. The graduated cylinders, so either the 25 or the 50 or 100 milliliter graduated cylinder. Graduated cylinders are only going to be able to read to 1 decimal place. The burette, on the other hand, which you'll also be using this week in lab, is going to be able to read to 2 decimal places. It's our most accurate piece of glassware for delivering liquids. So let's take a look at reading a meniscus and these examples that I have on this board here, and we'll determine what volume we're looking at. So it's important to note that when you're reading the meniscus, generally the rule of thumb is you can read 1 decimal place past the smallest tick mark on whatever instrument you're using. It could even be a ruler if you're measuring the length of something. So you have to figure out what's the distance of the tick mark, the smallest distance of the tick mark on the piece of glassware you're using. For this 100 milliliter graduated cylinder, so I can see here's the big mark that's at 70, and then there's 80 all the way up here, and I bet this is going by every 1. So that's probably 71, 72, 73, 74, 75. 5's a little bit longer, 76, 77, 78, 79, 80. So the tick mark here is going by every 1 milliliter. And again, rule of thumb, you can read 1 decimal place past that. So this graduated cylinder should read to the 10th place. So what volume am I at? All right, remember you get to eye level and you see where the meniscus is, and I would always count up so all the liquid would be down here, right? So I'm at 70, 71, 72, 73. I'm between 73 and 74 because that meniscus looks like it's just a little bit below 74. So I as a scientist would dub this as 71, 72, 73.9 milliliters. So this I would say is 73.9 milliliters. Again, that last decimal place is up to you to decide what value it is. There's more right answers. There can be more right answers, but there's not necessarily a wrong answer if you're reading your meniscus correctly. Someone else might have said that looks like 74.0. Yeah, I would buy that too. You know, like I might see it as being just a smidge under that 74 mark, but maybe they say, no, it's right on it. And so that would be 74.0 though. You have to include that 0 because again, graduated cylinders can read to the 10th place. So even if that number is a 0 that you want to put here in the tenths place, you have to include it because it is a significant figure. Okay, so let's look at the 25 milliliter graduated cylinder, because this one's a little different, a little trickier, but still only reads to the tenths place. So if I'm looking here at our 25 milliliter graduated cylinder, I've got a 15 milliliter mark, and then I've got my 20 milliliter mark up here. So this is 15, this is probably 16, 17, 18, 19, 20. Yeah, so these longer tick marks are the 1 mil, which means that these tinier tick marks are every 0.5 milliliters, so 0.5 milliliters. All right, so that's different than the other one. So how is it, you know, if the rule of thumb is you can read 1 decimal place past that, shouldn't this read to 2 decimal places? And the answer is no, because we're not that certain, right? Significant figures deals with certainty. So the space in between the tick marks here is every half a milliliter. So if you could divide this into 5 different spaces, right, that's just every 0.1 milliliter mark. So we can't read this 25 mil grad cylinder to the hundredths place. We can only guesstimate it to the tenths place, because again, even though this is a half a milliliter, you have to read that meniscus and kind of divide that into 5 different marks so you could read, you know, 16.1, 0.2, 0.3, 0.4, 0.5. So let's read what this meniscus is at. Remember, you would want to be at eye level with the bottom of the meniscus. So that looks like I'm at eye level with the middle or top. So let's make sure I'm at eye level with the bottom of the meniscus, right? And then you read from down going up. So here's 15 milliliters, 16 milliliters, it's 17 milliliters. It's between 17.0 and 17.5. And again, I can estimate. It almost looks like it's exactly ish between, maybe a little less. So if that's 17, maybe it's 17.1.2. Sure, I'll say this one I'm reading at 17.2 milliliters. All right, and that's because it's just a little bit less than halfway between those two. And the 2 distances here, it's a half a milliliter. So I'm going to say it's 17.2 milliliters. All right, so that's how we read our graduated cylinder. So graduated cylinders read to 1 decimal place, but burettes, on the other hand, which is our most accurate glassware, reads to 2 decimal places. And the reason that is because the tick marks are every 0.1 milliliter, and there's plenty of space for you to estimate in between. So again, remember, when you read a meniscus, you want to be at eye level, and you are going to look towards the bottom of the meniscus. And for burettes, though, it's slightly different. So graduated cylinders, you read from the bottom going up. Burettes, you read from the top going down. So at the top is the 0 milliliter mark, and at the bottom is the 50 milliliter mark. So it goes essentially 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you would read top down for burettes. So for example, my meniscus right here, I see a 33 milliliter mark and a 34 milliliter mark. So I'm between 33 and 34, and I'm going to read top down. So 33, 33.1, 33.2, 33.3, and it's a little bit past that. So this volume, I would say, is 33.32 milliliters. Again, burettes can read to 2 decimal places. So even if that second decimal place is a 0, you must include it, because you are telling other scientists how accurate your glassware was. So very important. So again, just to refresh or recap, reading a meniscus, you always want to read the bottom of the arc of the meniscus. Graduated cylinders are going to read to 1 decimal place. Include the 0. If you believe as a scientist that it's right on the mark and it's a 0, you have to include that 0 for your decimal place. Burettes are going to read to 2 decimal places. And again, for that second decimal place, even if you think it's right on the mark and it's a 0, you must write down that 0, because that is a significant figure, and it is denoting how accurate the glassware is you're using. All right. Feel free to ask us questions in lab. I'm sure we'll also cover it a little bit more during a pre-lab lecture. Have a great lab time.